speaker is from C-ASTRAL, Marko, and I don't even want to massacre his last name. I don't even see Marko. Marko, you're in the room. Oh, there he is. Okay, I do see you. He's up next. Big round of applause for Marko from C-ASTRAL.
Okay, perfect. Hello, good morning, good afternoon. I'm still on European time. It's great to follow Jonathan always, and to be, of course, the thing that's between my lecture and the lunch. But I will talk today about our business model, which is very old-fashioned. We actually build systems and integrate them for already for a very long time, as far as the youth of this industry is concerned. The company C-ASTRAL was born in 2008, and we have customers all over the world flying systems that have been accumulating more than 30,000 hours up to now. So we come from I-TASC. It's a very small town as far as small towns go where this kind of industry resides, but it's the center of the aerospace industry in Slovenia. Some of you might be familiar with the company Pipistrel in I-TASC, who has won the last green challenge for NASA for electric manned aircraft, for example. So we have some history there. I see that. So our products, systems, sensors, software applications, integration into GIS, geodesic survey, composite design, and electronics design. So we do everything that the big companies do, but a little bit more nimbly. So our basic family of systems is the Bramor UAS. This is how this is the platform that the company was built around. The Geo, the RTK, which is the latest addition, and the C4I, which is our surveillance ISR system. And all three of these systems are flying also in the US at the moment. And we're looking for more, of course, users and deployment in this country. We're launching actually today, and officially next week at AUVSI, our new system, the I-TASC, which we call the Advanced Technology Light Acquisition System, which is in comparison to the Bramor, which is 4.2 kilo maximum takeoff weight system that can fly for 3 hours. The I-TASC is your kind of not really entry level because it's very capable compared to the rest of the systems out there. But it's a 1 hour endurance system, hand launched, and capable still of doing a lot of the things that the Bramor does, but at a lower cost and more accessibility. You can go to much more remote areas with it because it's much lighter. You can see the mock-up of the I-TASC, of course, in the show. Our customers really come, we were able to create a customer base throughout these initial years of the introduction of unmanned systems. And our customer base is really, really wide. And it kind of stretches, of course, C-ASTRAL in many ways. It's also global. We really operate on all continents. We have customers flying in Antarctica, over the Arctic, and on every continent. So there's a lot of customer service kind of long distance issues that we are dealing with. And of course, the main applications you've seen also in Jonathan's presentation, surveying, geodesy, agriculture, that's where these systems are very, very useful. Surveyors can sometimes, with the current pricing schemes, pay off a system, depending on which market they operate, in literally a few jobs, maybe 2 or 3 if you are in New Zealand, or a little bit more if you work in Eastern Europe, right? So depending on the size of the market. But our initial systems that were starting to be used in 2011 the Bramor Geo, for example, in New Zealand for road surveys and so on, we're able to generate such return for these initial customers that they, thankfully for us, of course, bought more. And the question is really one of that also, Airware is addressing. How do you combine this value chain? Is every farmer really going to learn how to use an unmanned system? Is that even feasible? Does that make sense? Probably not. So it's really a question, and I think things are still open on that level. We have, of course, gone into this strange PowerPoint PC issue. Very nice. Well, I can, of course, point to what the figures mean, and we can do a short quiz. 16 meters per second is our airspeed, 33 meters per second is maximum. The endurance is 3 hours, up to 40 kilometers data link, autonomous catapult launch, autonomous waypoint array navigation system, parachute landing. Last year I presented here a lecture where I talk a lot about parachutes, but as a solution to the FAA problem. And here we are. Parachutes have seemed to be taking off at the moment, which is great to see. This very old Renaissance technology is finally, we figure out that it's very useful for unmanned systems. So the GEO is ideal for terrain mapping. That's its primary purpose. It has currently 24.3 megapixel sensor on. We have 2 different optics on the system, and we are kind of software agnostic. We have an onboard computer that provides output for all of the processing softwares out there. Since there is quite a few in the market with different approaches, even different mathematical approaches to the generation of mosaics and point clouds, and we like to support them all for the moment. Flight endurance of the GEO is up to 3 hours, and it lands with a parachute. And here it's the bird. The RTK is our newest addition. It's basically it's RTK, so because every surveyor knows what that means, real-time kinematic. But we are not doing real-time corrections in the air. That doesn't make any sense from any kind of usability point, because you still have to download the images after the flight is over, which are huge, right? After a 3-hour flight, you can imagine how many images you have, a few thousand, so we do post-processing kinematic on those images. The absolute accuracy of this system currently is kind of an industry standard from my point of view. The RTK has an absolute accuracy in the air of 0.8 centimeters on the X and Y, and 1.5 centimeters on the Z-axis. So it's an extremely precise measuring instrument, and that's why we designed it so. And we have kind of the ability to fly with it for 2.5 hours, even though it has a large payload in terms of the receiver and the onboard computer. And it just did a mapping mission, for example, at the China Lake Naval Air Station just this past month. Again, Macintosh, I love this. I should have just used my computer. This is the RTK data, very similar to the GEO, but the accuracy that I just talked about. We have a platform-agnostic mission planning software. With the I-TASC, we're introducing a new kind of software for mission planning, and with it you can have, of course, normal surface mapping, landslide mapping, road, mine mapping, pipeline surveys, power line surveys. You can do multiple geometries in one flight. You can use the now very, FAA and privacy-friendly geofencing and things like that. But basically, you have full control over your system. You also have full control over your system all throughout the flight. So you can change waypoints, upload new ones during the flight. You can evade an invading intruder aircraft or large predator and things like that. So these things happen when you do missions in extreme areas. We've been flying in Chile, for example, and a condor attacked a Bramor from the top, from above, and he didn't like the orange intruder there, and the Bramor the Bramor's fail-safes kicked in and he deployed the parachute, and Condor won 1-0. You've seen this a lot. We've been dealing with this mapping for years now. Our customers have achieved incredible accuracies with the kind of classical method with pre-measured ground control points, and now we are just starting to see the results also with our RTK system. Digital elevation maps, flood mapping. I mean, these are things we did in-house as demos years ago, and now, of course, it's kind of a normal processing chain that you see a lot. Landslide drift and rockfall simulations. Again, different types of. This is a quarry in Slovenia. This is, for example, a 5-centimeter precision. It's a very large area map of a power plant in Chile, for example. The C4I is kind of where C-ASTRAL goes onto the, if I may quote, whiplash, if some of you might have seen the movie, on big boy tempo. We are, the C4I is our ISR system, ISR asset. It's a very powerful system. It's now deployed with three military theaters and counting. So it's been in Afghanistan with the Italians. The system flies for 3 hours. It has a combined sensor payload that we used from Lockheed Martin and the Lockheed Martin Perceptor, and I know the AeroVironment is also using the same thing now on the Puma. That's what I hear. So it's been a while that we've been developing the C4I. It was actually how the company really started, and nowadays it turns into a very, very powerful ISR platform for kind of a more affordable economically for the end users. We have two types of ground control stations for the moment, but the system is very modular in its approach. So we really we have now developed an in-house auto tracking antenna, which our systems have incremental kind of development times. C-ASTRAL also has grown up to now completely organically. We never took a dime from any venture capital company and so on. So some of our developments are maybe a little bit slower than what you're used to here in Silicon Valley. But on the other hand, we take care of some of the issues that you have also seen here and were talked in the first talk, one of the first talks today, in terms of risk management and so on. So there's pluses and minuses to that. We collaborate with companies. Our alternative ground control station actually comes from our partners in Latvia, UAV Factory, also one great small Eastern European-based company in this space that has been working very, very well for years. The C4I is ideal for your classical, ISR. It's not hand launched. Our systems are these large systems are catapult launched, but that gives them a little bit more kind of security and robustness on the takeoff, and it has all of the bells and whistles of much larger ISR assets. The Bramor has a altitude record of 5,000 meters above sea level flight, and at least according to calculations, it could go higher. So 3 hours demonstrated 30 kilometers video link. We also developed the video link in-house. That we couldn't find anything sensible on the market, only crazy prices. So we put our heads together and the radio team together and created probably the world's smallest 30-kilometer range video link. And these are some pictures. These are our colleagues in Herat in Afghanistan with one of their Bramors, also mounted on the vehicle. You can see the tracking antenna and the ground control station inside. Parachute landing, our Arctic operations. Again, in 2009, 1 year after the company started, we decided to test the systems in the harshest environments, and we went to the Arctic and did a flight campaign there, and we went to the Antarctic and did a flight campaign there. So, we didn't have time to do normal test and evaluation. We decided to do expeditionary test and evaluation. And that turned out to be really, really good for the company because we had experience that nobody else in this space had when we kind of, put the systems on the market themselves. This is a minus 15 degrees Celsius takeoff in midday in European Arctic. One of our first customers in 2010 was a Finnish vocational college up in the Arctic, actually, and they established a unmanned systems training program to retrain people in the region to be unmanned systems operators and pilots. This was 2010 in Finland. So things have been happening for a long time in some parts of the world. Last but not least, C-ASTRAL is also, of course, we try to provide solutions to our customer base that is not only governmental and not only sovereign, right? You can imagine a lot of uses for an ISR system that is basically, not military per se. And one of the things that we've done lately is basically integrate the I have my clock here, so yeah, and on the screen too. We integrated, we did remote area projects like these that you see here. This is in Antarctica, in Droning Modland, sensor networks, communications, mapping projects, and analytical projects on the SIGINT side. So there's a lot of knowledge in the area where we operate in Slovenia, also on those levels. This is, for example, a genocide mapping from Srebrenica. It's going to be 20 years this year of that, and we created not with any unmanned system, but with other types of software. We created these maps of the electronic communication. So that's one of the capabilities that we can provide. We also are working with a small Slovenian company developing the Battle Eye system. Is your kind of battle space management system, but the thing with the battle space, welcome to Macintosh. The thing with the battle space management systems is that they are, of course, extremely expensive, something that is out there, something that the large contractors are taking care of, and so on. But you can imagine that for example, an ecological monitoring organization or, an organization that takes care that regulations are clearly enforced and so on the environmental side, this kind of system that you can be very, very useful. It's basically a conversion of a kind of a military paradigm down to something that, the battles can be very different. They don't need to be only kinetic, right? So this battle eye system is something that we are integrating completely into our chain for end users. So all of the systems are also very, very customized and customizable. C-ASTRAL has over the years done a lot of internal development. One of our last projects was a integration of a mass spectrometer, laser mass spectrometer on the Brahmer system. It's flying now in northern Canada, monitoring pipelines at 50 meters AGL, and I just got the results today that they are able to detect 2.5 parts per million of methane with the system. So 2.5 ppm with the laser spectrometer built on a platform flying for 2 hours over the Arctic. So we're very proud of that. And 20 minutes and I'm done. Thank you.